Hi. Welcome to Digital Learn. Today we are talking about atomic structure. We are talking about this for tropic. See it at a glance. What is atom? An atom is the smallest particle of the element that can exist independently and retain all its chemical properties.
Discovered of atomic structure. 1. By Thomson proposed that A. An atom consists of a positively charged sphere and the electrons are embedded in it. B. The negative and positive charges are equal in magnitude. So, the atom as a whole is electrically neutral. Two. By Rutherford proposed that Rutherford's alpha particle scattering experiment led to the discovery of the atomic nucleus. Rutherford's model of the atom proposed that a very tiny nucleus is present inside the atom and electrons revolve around this nucleus. The stability of the atom could not be explained by this model. Three. By Niels Bohr proposed that Niels Bohr's model of the atom was more successful. He proposed that electrons are distributed in different shells with discrete energy around the nucleus. If the atomic shells are complete, then the atom will be stable and less reactive. Four. By Chadwick proposed that J. Chadwick discovered presence of neutrons in the nucleus of an atom. So, the three subatomic particles of an atom are I. Electrons, 2. Protons and 3. Neutrons. Electrons are negatively charged, protons are positively charged and neutrons have no charges. The mass of an electron is about 1/2000 times the mass of an hydrogen atom. The mass of a proton and a neutron is taken as 1 unit each. Basic concept of atomic structure. We know that protons are present in the nucleus of an atom. It is the number of protons of an atom, which determines its atomic number. It is denoted by Z. All atoms of an element have the same atomic number, Z. In fact, elements are defined by the number of protons they possess. Mass of an atom is practically due to protons and neutrons alone. These are present in the nucleus of an atom. Hence protons and neutrons are also called nucleons. Therefore, the mass of an atom resides in its nucleus. Isotopes are atoms of the same element, which have different mass numbers. Isobars are atoms having the same mass number but different atomic numbers. To bind a nucleus together, there must be a strong attractive force of a totally different kind. It must be strong enough to overcome the repulsion between the positively charged protons and to bind both protons and neutrons into the tiny nuclear volume. This force is called nuclear force. The nuclear force is much stronger than the Coulomb force acting between charges or the gravitational forces between masses. The nuclear force between neutron-neutron, proton-neutron and proton-proton is approximately the same. The nuclear force does not depend on the electric charge. Basic concept: radioactive nucleus. Radioactivity occurs when an atomic nucleus breaks down into smaller particles. There are three types of nuclear radiation: alpha, beta, and gamma. Alpha particles are positively charged, beta particles are negatively charged, and gamma particles have no charge. The radiations also have increasing levels of energy, first alpha, then beta, and finally gamma, which is the most energetic of all these. Alpha and beta are particles, but gamma is a wave. When a radioactive nucleus changes, the remaining nucleus and atom is not the same as it was. It changes its identity. The term half-life describes the time it takes for half of the atoms in a sample to change, and half to remain the same. There is even a radioactive isotope of carbon, carbon-14. Normal carbon is carbon-12. C14 has 2 extra neutrons and a half-life of 5,730 years. Scientists use C14 in a process called carbon dating. This process is not when two carbon atoms go out to the mall one night. Carbon dating is when scientists try to measure the age of very old substances. There are very small amounts of C14 in the atmosphere. Every living thing has some C14 in it. Scientists measure the amount of C14 in the things they dig up to estimate how old they are. They rely on the half-life of 5,730 years to date the object. Fission is the splitting of an atom. Not all atoms will go through fission. As a matter of fact, very few do under normal circumstances. In a nuclear reaction, scientists shoot a whole bunch of neutrons at uranium-235 atoms. When one neutron hits the nucleus, the uranium becomes U-236. When it becomes 236, the uranium atom wants to split apart. After it splits, it gives off 3 neutrons and a lot of energy. Those neutrons hit 3 other U atoms in the area and cause them to become U-236. Each cycle, the reaction gets 3 times bigger. A reaction that, once started, continues by itself, is called a chain reaction. Fusion is the process of 2 small atomic nuclei coming together to make a larger nucleus which is stable. The simplest nuclei to use are deuterium and tritium. So, like, share and subscribe the channel, and hit the bell icon to get more update. Thanks for watching.